Hello everyone. Today I am going to discuss some important things regarding white box testing. White box testing follows a see-through box concept. And what is that? Uh, in a white box, the inside the box there is full of light. That means whatever happening inside the box we can see properly. Okay, so that is the concept of white box. Just check this, and assume that this is a white box and the balls at the bottom, they are maybe code or the processes. Okay, and how they are running, okay, or how they are moving, okay, that is clearly seen by the outsider. Okay, so like this, the testing team will have the knowledge of the inside architecture, okay, or the structure or the design, and the coding also, okay, in this case, so they can verify each of them. So white box testing is based on analysis of the internal structure or component of a system, or we can say that this is a test of internal structure, design and coding, right? And white box testing is also known as clear box testing or open box testing, structural testing, transparent box testing, code based testing or glass box testing. Now, what is verified in white box testing? Internal security holes. Okay, if there is any fault in security, that can be verified. Okay, broken or poorly structured path in the coding process, that is also verified in white box testing. The flow of specific input through the code, expected output based on some input, okay, functionality of conditional loops, so all the loops will be tested, that means all the iteration will be tested, testing each statement, object and function on an individual basis. And how this all will be verified will come one by one later in this video. Okay, now one thing we should remember that this white box testing can be applied at all levels of SDLC. Okay, so this is a very important thing. Now testing, this testing can be done at a system level or integration level or unit level in software development. Now what is the goal of the white box testing? Okay, the its aim is to verify working flow of an application. Okay, now if we talk about the techniques of white box testing, okay, we'll have these four testing technique of white box: statement coverage, branch coverage, condition coverage, path coverage. So these four techniques will follow in white box testing. Okay, and from top to bottom they are becoming stronger. Like branch coverage is stronger than statement coverage, condition coverage is stronger than branch coverage, and so on. Okay, now coming to the first one, that is the statement coverage. In statement coverage, it aims to design test cases so that every statement in the program is executed at least once. And it is very hard to determine if an error exists in a statement unless the statement is executed. How? Let us consider this program. In compute xy, int xy while x not equals to y. If x greater than y, then x equals to x minus y, else y equals to y minus x, and this is the end of the loop. Then return x, and then the end of the function compute, right? So in this algorithm there are many statements. Okay, so each and every statement will be checked or verified here in white box testing by the technique of statement coverage. And why, how? Like, see, suppose we consider this Ax not equals to y, this condition can either be satisfied or it can be it may not be satisfied. That means it can be true or it can be false, okay, in turn. So if it is false, then that means x equals to y, then this return x, directly this statement will be executed, right? So for that we'll check a test case where x and y both are same, both will have same values, like x equals to 3, y equals to 3. Now suppose we want to enter into this section of the program, like while x not equals to y. Okay, so not equals to x not equals to y, there can be two options, either x can be greater than y or x can be less than y. Okay, so let us take x equals to 4, y equals to 3, that is x greater than y. So if x greater than y, then we will go to this if statement, x is greater than y, then this x equals to x minus y will be executed, this statement. Now if it is not greater than y, let us take another example, another test case, x equals to x equals to 3 and y equals to 4. So if it is there, then this if x greater than y, it is false, so this else will be executed and y equals to y minus x will be executed, right? So these can be three test cases by this test set. If we generate this test set with the test cases where the elements are test cases, like both of them x and y are same, x and y, x greater than y, here x less than y, then all these statement will be executed. Okay, so this is actually statement coverage. That means all the statement will be covered, will be verified by this technique, and that is called statement coverage, right? Now coming to the branch coverage, it is also called decision coverage. Now here test cases are designed to make each branch condition to assume true and false values in turn. It is also known as edge testing, as in this testing scheme each edge of program's control flow graph is traversed at least once. Now what is control flow graph and what is edge, we'll come to this later in this video. Okay, before that just check all the branches will be checked. Okay, now here all the branches will be checked. Suppose if x greater than y, and if it is true, then this statement will be executed. If x less than y, then the y equals to y minus x, this statement will be executed, right? So coming to this, just check this one, x greater than y. If it is true, that is yes, then x equals to x minus y. And x greater than y, if it is false, then y equals to y minus x will be executed. So we can see the two branches are coming out from this statement, x greater than, from this condition x greater than y. Sorry. Now both of these branches will be checked or verified, that is called branch coverage. So each and every branch will be verified in this testing technique. Now one thing you see in this branch coverage, the statements are also executed or verified, right? So if we go for branch coverage, statement will also be covered here. That's why branch coverage is a stronger technique than the statement coverage. Okay, now and as I said, control flow graph, we'll discuss this later. Now in condition coverage, it is also called multiple condition or MC coverage. Now here test cases are designed to make each component of a composite conditional expression to assume both true and false values. Okay, so each condition will be checked. Here x not equals to y, this is a condition. This condition will be checked or verified by making it true value and the false values in turn. Similarly x greater than y, that will also be checked, okay, with true value and false values. And you can see if the conditions are covered, then all branches will also be covered. That's why condition coverage is stronger than branch coverage, and branch coverage, as branch coverage also covered this statement coverage, so branch coverage is stronger than statement coverage. Okay, now coming to the path coverage, the final one, that is the path coverage. The aim of the path coverage is to design test cases such that all linearly independent paths in the program are executed at least once. So a linearly independent path can be defined in terms of the control flow graph. So you can see for this we have to know what is path coverage, what is control flow graph. Okay, and if we want to know control flow graph, then first of all we have to know what is a graph, right? So a graph is a combination of nodes and edges. Okay, now see, look at this picture. Here K is suppose we have 4 metro cities in India: Kolkata, Mumbai, Delhi and Chennai. So this K, D, M and C are representing 4 cities. Okay, now these cities are represented by nodes. These are called nodes or the endpoints, right? And the path which are connecting these two cities, these are called edges. So M to D is, it is one edge, D to K there is also another edge. Okay, like these all these are edges. Okay, and as you can see, these can have the direction. If there are direction, then it will be directed graph. It is called directed graph. Okay, so coming to the CFG, all the statement of a program must be number first. Sorry, before that, what is a CFG? It describes the sequence in which the different instruction of a program get executed. Okay, how the control flows through the program. Okay, now suppose you can see this program. If you consider this program, how the program counter will flow throughout the program and how the statements are executed one by one, that will be shown by the control flow graph graphically. Okay, now how if we want to show the control flow graph, we have to generate the control flow graph, and then we have to know how to draw the control flow graph or CFG. First of all the statement of the program must be number first. Okay, then just check this one. Here in this program, the same program what we are discussing, same program. Okay, now first we have to give the numbers. So we have to number all the statements one by one, right? And this will be in sequence. Okay, and how the process, how the control will go from one number to another number, one statement to another statement, that will be shown by the control flow graph like this. Okay, how to draw, I am coming to this later. Now the different number statements serve as node of CFG. See, 1 2 3 4, these are the statement. Okay, so these are the nodes. These are represented by the nodes. Okay, next one, each from one node to another node exists if the execution of the statement representing the first node can result in the transfer of control to the other node. Now here you can see from 1 the program counter will go to 2, because after 1 it will go to second line. Okay, after that it will go to third line. So 1 to 2 there is a connection, so it is a directed edge. Next 2 to 3 there is also another connection. By this way we can generate all the edges, right? Next, different types of statement representation. So like there may be sequential statement. Okay, there may be if else statement. Okay, that is decision and then there may be iteration or loops, right? So how to represent a sequence? Suppose if you consider this program segment, a equals to 5, b equals to a into 2 minus 1. So you can see that from 1 it will directly go to 2. So that is sequence. Like in this section, 1 to 2, 2 to 3, 1 to 2, 2 to 3, these are sequence. Okay. Now selection or branching. Here for decision statement, like if a greater than b, then c equals to 3, else c equals to 5, then d equals to c plus plus. See, as you can see, from 1 it can go to 2 if it is true. If it is not true, then it will go to 3, that is the else, and c equals to 5. So, and in both the cases, after the end of the if statement, from 2 to 4 and 3 to 4. So from 1 to 2, 2 to and if it is true, then 1 to 2. If it is false, then 1 to 3. And in both the cases, 2 to 4 and 3 to 4. Right? That is the end of the, after ending the if statement, it will directly go to 4. So 2 to 4, 3 to 4, there will be different paths. So by this way, we can represent branching. Okay. Now you can remember that in previous section we have talked about the branch coverage. Okay. So each or it was also known as edge testing. As in this testing scheme, each edge of a program control flow graph is traversed at least once, right? So in branching, each edge of each branch will be tested at least once, right? So that is called branch coverage. Next one, what is iteration? Iteration can be represented by this. Maybe there is a while loop, and as you know, while loop is the entry control loop. Okay. So while a greater than b, then block is started, the body of the loop is started, then b equals to b minus 1, c equals to a plus b, and then the body of the loop is ended here. Okay, right? So it is the end of the loop, and after that return c. Now here you can see from while 1 to 2 there is a linear motion. So 1 to 2 there will be an edge, then 2 to 3, yes, 2 to 3, 3 to 4 directly, 3 to 4. Okay, so at 4 there is the end of the loop. Now should we go to 4 to 5 or should we not? No, because while loop is entry control loop, as a condition is checked at the beginning, so 4 to 1 it will directly go, and this is the iteration. Okay, like this, and until this condition is dissatisfied, that is, the value of a greater than b will be false or 0. So if it is false, then it will go to 5 from 1 from the beginning of the loop, as it is entry control loop. If it was do while loop, then from 4 to 5 was there was a path. Okay, but here from 1 to 5, as it is entry control loop. I hope you have understood this one. So we can proceed to the next section, that is the path. What is a path? A path through a program is a node and edge sequence from the starting node to a terminal node of the CFG of a program. Now here, suppose we want to check the path from 1 to 4. So 1, this edge, 2, this edge, 3, this edge, and 4. This is the path from 1 to 4. Suppose we will consider path from 1 to 9. See, 1, 2, 3, 4, 7, 2, 8, 9 is one of the path. Again, 1, 2, 3, 5, 6, 7, 2, 8, 9, another path. So we can get two paths here. Okay. Next, what is linearly independent path then? Any path through the program that introduces at least one new edge that is not included in any other linearly independent path. Any path having a new node automatically implies that it has a new edge. a path that is a subgraph of another path is not considered to be a linearly independent path. Now just check from this example. As I told you, 1 2 3 4 7 2 8 9, this is one path, so it is one of the path from 1 to 9. Again 1 2 3 5 6 7 2 8 9, as I said, this is another linearly independent path. This is different from this path. Okay, so these two paths are completely different. They are linearly independent paths because from the first path 5 and 6 were not present. Yeah, these two are new nodes which are included. Okay, so if any path includes a new node, okay, then it will automatically it will add a new edge, right, and that will be another linearly independent path. So both of them are linearly independent from each other. Okay, now what is path coverage? In the path coverage, in the path coverage testing does not require coverage of all paths but coverage of linearly independent paths. Okay, so those paths which are linearly independent, these will be checked in path coverage only. Now coming to the cyclomatic complexity. Okay, actually cyclomatic complexity is a software metric used to measure the complexity of a program. Okay, it defines an upper bound of the number of linearly independent paths through a program, and remember, it determines the maximum number of linearly independent paths in a CFG of a program and does not directly identify the linearly independent path, but it informs approximately how many paths to look for. That means it will not detect how many linearly independent paths are present in the CFG or the control flow graph, but it will, the cyclomatic complexity will find or will define the maximum possible number of linearly independent path in a CFG. Okay, so the how to compute the value of the cyclomatic complexity for a program or a program segment. Okay, there are several methods. First of all, before going to that those methods, we have to know how to generate the CFG from the program. So as I have told you earlier that these are numbered, all the statements will be numbered first. According to these numbers, we have to draw the CFG. So each statement will be represented by each node, these numbers. Okay, and how the control will flow, just check. From 1 to 2 there is a linear path, okay, direct path. Then 2 to 3, yes, 2 to 3. See, in 2 to 3 there is if statement, so x greater than y. If it is true, then it will go to number 4, so 3 to 4. Okay, again if it is false, then it from 3 it will directly go to 5, and from 5 it will this 6, number 6 statement will be executed. So 3 to 5, 5 to 6, and from 6 after the end of the if statement it will go to 7. Also from 4 it will directly go to 7. If it is satisfied, then it will not go to the 5 part, that is the else part. So 5 6 will not be executed. From 4 directly it will go to 7. That's why 4 to 7 and 6 to 7 there will be edges. Okay, now it is the 7 is the end of the loop. So after the end of the loop, as you can see, while is the entry control loop, so again it will be iterated and it will go to 2. So 7 to 2 until it will be satisfied, it will move in this direction or it will be iterated. Okay, now when this will be false, that is this x not equals to y, will get the answer no. Then from 2 it will that is the end of the loop. So from 2 this body will not be executed anymore, and from 2 it will be directly going to 7, sorry, directly going to 8, right? So from 2 directly 8, return x, and after that at 9, 8 to 9 there will be a linear path, so 8 to 9. So by this way we can draw a CFG. See here in this program segment, branches are there as well as iteration there, okay, and sequence is also there. Okay, right now for method 1, what is the method 1? Cyclomatic complexity Vg equals to E minus n plus 2p, where E is the number of edges, n is the number of nodes, p is the number of connected components. From what is the number of edges in this graph, we can easily calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the number of nodes? Easily you can find the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So E equals to 10 and N equals to 9. Now what is this P? P is number of connected components. So now let us consider this graph. To understand connected component, graph is it is also called connected graph. It is an undirected graph. That means there will not be direction. We don't have to consider these directions. Okay. At least one path is there between any two vertices in the graph. So from D to C there will be at least one path. It may be DEMC or DKC or DKMC or DMKC. Don't consider these directions. It can go to any direction. That means there exists one path. So all these, all these nodes are connected to each other, maybe directly or indirectly. See, D and C, there is no direct connection, but there D and C are connected via M or via K. So there is also another path. Now, if we consider these 4 metro cities, they are all connected. Now, consider as a whole India and Sri Lanka. Maybe Sri Lanka has, if we consider 3 cities of Sri Lanka, Jaffna, Colombo and Galle, right? So they are connected because there are roads, but suppose these are roadways, okay? We are not considering the waterways or airways, only roadways, as we know that there is no road connection from India to Sri Lanka. So no two cities from both the each one will be considered from each country, okay, one from India and one from Sri Lanka, they are not connected. Okay, so DKMC, these are connected. Jaffna, Colombo, Galle, they are also connected. But as a whole, if we consider this graph, all the nodes are not connected. You can see the gap here, right? So here we can get 2 connected components. But in this program segment, we are getting only 1 connected component, because from any node to another node, you can have at least one path. Okay, so if there exists at least one path between any two nodes, there will be that is connected graph. Okay, normally in our exam question we'll get the program segment like where P, most of the time P will be 1. That's why in some book you will find the formula is written like Vg equals to E minus N plus 2. Okay, but it is better to use this P because there can be more than one connected components. Okay, so here as we can see in this graph, there is only one connected component, so it is 1 only. So as we have got the values from E, N, E is 10, N is 9, okay, number of edges and number of nodes, and P is 1, so we are getting 3 as the value of Vg, right? Now coming to the next method, okay, Vg equals to, that is the cyclomatic complexity, Vg equals to number of bounded areas or closed region plus 1. See, number of bounded region here, this is considered as one bounded region, and also 2, 3, 5, 6, 7, 2, this is also another bounded region. or closed region, but we cannot consider 2, 3, 4, 7, 8, 2, because see, there is a gap, it is not bounded. Okay, there is a path, there is a gap. Okay, so as there is open region, so they will not be considered as bounded region. So how many bounded region we can get from this graph? Only two, one and this two, right? So 2 plus 1 is 3. Again, method 3, cyclomatic complexity Vg equals to number of predicate nodes plus 1. Predicate nodes are actually decision statement, nodes which have the decision statement or the conditions. Okay, now in how many nodes we have the conditions? See, node 2, it has a condition. Node 3, it has also another condition. Okay, so these two will be these two will be considered as predicate nodes. And another thing, how to find the predicate node in an easier way? Just see, if from some node branches are coming out, more than one branches are coming out, then that will be considered as a predicate node. Okay, this is a trick. So say from 3, as it is having a condition, so it can be either true or false, so that's why two branches are there. Again, from 2 there is a condition, see, 2 to 3 and 2 to 8, two branches. So we are getting two predicate nodes in this given in this drawn CFG or control flow graph. So 2 and 3, so number of predicate nodes are 2 here and plus 1, so 3. See, all the by all the method you will get the same value or the same answer. Okay, and if you are not getting the same answer, then there may be some error or fault in your calculation. So they all of them should be same. Now coming to the complexity range, this value can be 1 to 10. If 1 to 10, then it will be high testability is there for that program. If the value is 10 to 20, that is a complex code and medium testability is there. And if it is 20 to 40, then low testability, okay, very complex code. And if it is greater than 4, it is not at all testable. Okay, it needs very high cost and effort. So which one is best? If the value is less than 3, that code can be tested by this McCabe's cyclomatic complexity. That code can be tested by white box testing very easily. Okay, so we have to remember these values. So that's all about the cyclomatic complexity, McCabe's cyclomatic complexity, as well as the white box testing. Okay, now I hope you have understood what is white box testing. If you have any question, you can ask in the comment section. I will try to answer all the queries. Thank you.